Hello, my name is Keshwani. That's Keshwani, Keshwani. I have been solving math problems for GRE out of this book here, practicing to take the GRE General Test, the 10th edition. If you do not own this book already, purchase it immediately. The problem that I'm about to solve is the one that you're going to find on page number 266, not 265, page 266. Page 266, the very first problem, number 11. This exam is from the old-fashioned days, back in the old days when the exam used to be given in the paper and pencil format, and the questions used to be arranged in the order of difficulty, and they used to give you 15 questions, 15 quantitative comparison questions in a set. And since there were 15 of them, everybody knew that the first 4 were easy, the next 4 were medium, and next 5. The first 5 were easy, the next 5 were medium, and 11 through 15 were hard. This is the hard questions. Or if I should probably say supposedly hard question. We'll take a look at it. It says, it's important that you have the book in front of you so that you can follow me. Read, open, turn to page number 266, question number 11, and read the problem with me. Don't just depend on listening to what I'm saying. It helps to have the problem in front of you. It says, and if you don't own the book by now, you buy one immediately, as I said in the beginning. It's very important. Don't waste your time and money practicing for the exam, getting ready for the exam, practicing the fake exams that are out there on the market. Buy the real thing. This is it. This book contains 7 real exams. It says, on a turntable, a record of radius 6 inch is rotating at a rate of 45 revolutions per minute. Alright, so we have a record with a radius of 6 inches, and we are told that it is rotating at the rate of 45 revolutions per minute. 45 revolutions per minute. Alright, so far so good. In column number 1, we are given a quantity. We are told that we are asked to figure out the number of inches traveled per minute by a point on the circumference of the record. Well, if a point is right on the circumference, let's pick this point for example. If the point is right on the circumference, then every time it makes 1 revolution, how much distance does it cover? That's the very first thing you have to figure out. How much distance does a point travel, a point sitting on the circumference of a wheel, or what, as they say here, a record, or whatever it is, any circular object. If it goes around 1 time, how much does it travel? Well, that comes from a concept of circumference, and I hope you know that by now. A circumference is simply 2 times pi times r, 2 pi r. So here in the first column, we have 2 times pi times r, which I know is 6 inches. This is how much distance, this is how many inches it will travel in 1 revolution. And since we are being asked how much does it travel in a minute, and we are told that the record is moving at a rate of 45 revolutions per minute, it will travel 45 times as much distance. This is how much it travels in 1 revolution, and since it's making 45 revolutions in a minute, this is how much distance this point travels. Let's call it point A. Now let's look at point B. Where is point B located? The number of inches traveled per minute. How did I know there was going to be point B? Don't ask me. The number of inches traveled per minute by a point on a record 5 inches from the center. So this is very important. Now we're being asked how much distance a point would travel that is only 5 inches from the center. Well, if it's from 5 inches from the center, we're talking about a point like this. Excuse me. Well, in 1 revolution, it's going to travel this much. I shouldn't have put the 6 there. This is our point B. And the point B is 5 inches from here. Well, you really don't have to do anything. Just use your common sense. If it's only 5 inches, each time it travels 1 revolution, even if you didn't know the formula, your intuition should tell you that if it's sitting closer to center, each time it travels 1 revolution, it's traveling less distance than the point that is farther away from the sentence. That's what it is. In other words, if you use your intuition will tell you that if I were to travel 1 mile, and if I have 2 different sizes of tires, a bigger tire will travel fewer revolutions in order to go 1 mile. A huge tire will have to go a fewer revolutions to travel the same amount of distance as a smaller tire. That's what it is here. So in column B we have, again we have 2 times pi times r, which is 5 now, times 45. And we are being asked to compare these two quantities. But always keep in mind, these questions are called quantitative comparison, which is why I make a point of writing down the word computation. I actually write down the word computation and then I cross it out for emphasis. It is not about computation. We're not going to sit there and waste our time trying to figure out this bloody thing. It doesn't matter. It's very simple. A point that is only 5 centimeters from the center is going to travel less each revolution, and therefore in a given minute it's going to travel less distance than the point that is farther away from the centers. Or if you want to look at more mathematically, this is what's going on. This 2 cancels out, this pi drops out, this 6, this is our radius for this one, this is this one, and this 45 goes away. In other words, if we were to divide both sides of the, I was going to say both sides of the equation, but this is not an equation. If we were to divide both columns, column A and column B, by this quantity, if I were to divide 2 times pi times 45, I can do that. Why not? 2 times pi times 45 will get rid of all of this thing. 2 cancels out with 2, pi cancels out with pi, 45 cancels out with 45. I can do that as long as I do the same thing to both columns. As long as it's a positive number, I can divide this quantity by some positive quantity, and I can divide this column by the same quantity, and it's not going to change the directions of the inequality. So as you can see, 6 is bigger than 5, obviously, that's all. I'm probably making too much fuss about nothing at all. The answer is B. Sometimes I feel like I have a tendency to beat a dead horse, I think is what the expression American use. But anyway, this is it. I hope you found it helpful. If you wish to get hold of me, either for personal private tutoring, face-to-face personal private tutoring, or I do tutoring over the phone, wherever you are in the world, wherever you are in the country. I do tutoring over the phone or over the internet, or if you wish me to send you some solution manuals to these problems, for any reason at all, if there is anything that I can help you with to get you ready for GRE, or for that matter GMAT, if you're going to take that on. I don't know why it says GMAT. We are doing the GRE. Let me change that. Both of those URL, prep for GMAT and prep for GRE, will take you to my website. Get hold of me and send me an email, and we'll see what we can do for you. This should be prepforgre.com. I don't know what I was thinking, but as I said before, prepforgre.com or prepforgmat.com, they will both take you to this website, www.KeshwaniPrep.com. Alright? Thank you very much. Send me an email and I'll help you out. Thank you. Bye-bye.